In this video, we will learn about Ohm's law. Ohm's law states that the voltage across a resistor R, so if you look at the points X and Y, the two terminals of the resistor, then the voltage drop across this resistor, so we call it V, from this point to this point. The voltage drop V is equal to the current flowing through the resistor. We call it I here. So is I multiplied by the resistance R. Or we can also say that the current flowing through the resistor is voltage across the resistor divided by the resistance of the resistor. So if you look at the units here, so voltage is volts, I is in amps, and R is in ohms. So now what it means here is, say look at a circuit, a simple circuit. Let's connect a DC source of value V in across a resistor of value R, and then we complete the circuit. This is the ground here. So now a current flows through this circuit. That current I is equal to V in over R. So for example, say V in is 3 volts and the resistor R is say 1.5 kilo ohms or 1500 ohms. So the current I would be 3 volts divided by 1.5 kilo ohms, which would be 2 milliamps. Now let's assume, so the Vn is still the same. Vn is 3 volts, but the resistance R is now say 300 ohms. Now the current would be I would be 3 volts divided by 300 ohms, which can also be written as 3000 millivolts over 300 ohms, which is 10 milliamps. So this is one way of explaining. And then the other way of explaining a resistance is you can have a different kind of circuit where you actually have a current source forcing a current into the resistor R. So you're forcing a current I into a resistor R. Now we look at the voltage developed across this resistor, VR. So VR is I multiplied by R. So again, if you look at, so assume we have an R is 1 kilo ohm, and then I in, we call it I in here. We're forcing a current. Say I in is 1 milliamp. So the voltage would be 1 kilo ohm multiplied by 1 milliamp, which would be 1 volt. So now if you look at the resistance, like say let's plot V on the x-axis or voltage, the current on the y-axis. Now, since we know the relation of the current through the resistor, I is V over R, or V is I times R. So you would always have curves like this for the resistance. So it's 0 volts, and then say you're increasing your voltage 1, 2, 3, 4, 5 volts here. So if you have a certain resistance, you got a straight line curve here. Then if you lower the resistance, what happens is the current starts increasing faster. So you will have a curve that will look like that. So you have more current for the same applied voltage. If you keep increasing the resistance, the curves become closer and closer to the x-axis. So this is where you're increasing, R is increasing. So if you decrease the resistance, the curves will look like this. For very low resistance, it could be like this. But it's always a straight line, it's linear. The relationship between voltage and current in a resistor is linear. And then there are certain other effects where sometimes there could be the resistance would vary with temperature. And in integrated circuits, sometimes the resistance also varies with the applied voltage. And this happens only in usually in ICs, because you got something called a substrate, and then say if you have a resistor like this, few resistors, say 4 resistors, polysilicon resistors, and then you apply a VDD voltage here, which could be say 1 volt, and then each resistor is 1 kilo ohm. So this resistor drops 0.25 volts. So here the voltage would be 0.75 volts here. Then it would be 0.5 volts here, because all are equal resistors, 0.25 volts here. But sometimes what happens is the resistor which is on the top string may have a different resistance compared to what is in the bottom. So that is called voltage coefficient of the resistor. And resistor varying with temperature is normal. It happens especially in ICs, it happens a lot, and then I will discuss that in a separate video. So what we know as R is varies with temperature. I cannot say whether it's inversely proportional or proportional, so it depends on what kind of resistor it is. So usually resistances will lower with temperature, or varies with temperature, and there is a temperature coefficient associated with that, and it depends on the material type. So some materials may have a positive temperature coefficient, some materials might have a negative temperature coefficient. And also we talked about R varying with applied voltage, which happens only in ICs usually with voltage. That's called a voltage coefficient. That depends on where the resistor is placed. So the resistor, which is between 0.25 volts and ground, might show a little bit slightly different resistance compared to the resistor that's placed between 1 volt and 0.75 volts. So in this video we learned about the Ohm's law, the relationship between I and R in a resistor, and we applied a voltage across the resistor and measured the current. We forced a current into the resistor and measured the voltage across the resistor, and then we also saw how the curves, the IV curves look like for the resistor. Also we briefly discussed about resistor varying with temperature, and also in integrated circuits where the resistance varies with where it is placed in terms of voltage range, where the resistor is placed in the voltage range.